So in this section, we're going to talk about the addition of coplanar or 2D forces using Cartesian notation. Okay, so often you might be asked to solve for the sum of more than just two vectors. So in that case, it's often easiest to use Cartesian notation. So you can represent any vector in two dimensions using the addition of its x and y components. So let's say you had let's just draw two axes where we have our x-axis and our y-axis, and we will then draw a force vector F. All right. So what we can say, or what Cartesian notation says, is that our force F would be equal to the addition of its x component plus its y component. Okay? All right. So its x component we can draw along the x-axis. All right, fxi, and then its y component we'll draw along the y-axis, which we'll draw as fyj. All right, so f of x and f of y are the magnitudes of the x and y components of our force. And then I and j, or I hat and j hat, are unit vectors, which means they have a magnitude of 1. So I and j have a magnitude of 1. And the I and j are directed about the positive x and y axes. So x corresponds with I hat, and the y axis corresponds with j hat. Okay? So the really nice thing about using Cartesian notation is you can add a lot of forces together really, really easily. So if you had, for example, acting on a single point, all right, you had three forces. Let's say you had force 1, you had force 3, and you had force 2. And let's say that if you add those three forces together, you want to determine what is our value of r theta. Okay, so determine what is our resultant force and what is the angle or direction of that resultant force. So to determine it, we can use Cartesian notation. So we can say our resultant force will be equal to the sum of all the forces on our system. So in this case, it's going to be equal to force 1 plus force 2 plus force 3. Okay? So to do this vector algebra, what we're first going to do is we would place F1, F2, and F3 in Cartesian form. So we would define F1 in terms of its Cartesian components. So we could say F1 would have an x component times the unit vector along the x-axis I plus F1 component along the y-axis, which would be F1y times j. And we could repeat this problem for F2 and force 2 and force 3. So if we just copy that down, we would get F2x times I plus F2y times j. And then we would get, for force 3, we would get F3x times I plus F3y times j. Okay, so now we have all of our components in Cartesian form. So what we can then do is we can solve for our resultant force. All right, so we can say that our resultant force would be equal to force 1 plus force 2, force 1x plus force 2x plus force 3x times the unit vector I plus force 1y plus force 2y plus force 3y times j. Okay? So in general, we can always say that the resultant force or the resultant vector for the sum of any amount of vectors is equal to just the sum of all the x components times I plus the sum of all the y components times the unit vector j. All right. So if you have those two equations, so once you have your resultant vector, you can determine the magnitude of the resultant vector would just be equal to the square root of the sum of all of our x forces squared plus the sum of all the y components of all of our forces squared. All right. So this is just the Pythagorean theorem. All right, and then the angle theta, or the direction of our resultant vector, would be equal to the inverse tangent of the sum of all of our forces in the y direction divided by the sum of all of our forces in the x direction. Okay? So using the Cartesian notation, it's really simple. If we have all of our vectors and we can define them in terms of their x and y components, we can just add all the components together algebraically, and then once we have the total x component and y component of the resultant vector, we can solve for the magnitude of it by taking the square root of the sum of the squares, and then we can find the angle using the inverse tangent function. All right. So that concludes this video on addition of forces in 2 dimensions.